Right, good day everyone. Oh, I said right, I shouldn't have said right. Welcome to Corona AP Maths. It's all happening here in the house. Good wife is making soup for the children. The dishwasher's on, so I do apologize for any interruptions and strange noises. Okay, domestic life does not halt for AP Maths. No compromises, I'm afraid. So, okay.
Leek and potato soup.
Leek and potato soup. Right, so you've watched the other videos about E, where it comes from, what it does, where E is basically, it's an irrational number, just like pi is, and it's got some very special properties. Okay, and it's fundamentally the limit as n tends to infinity of 1 plus 1 over n to the n. Excuse the chopping going on in the background. Those potatoes are being cut. Right, okay. So E is limit as n tends to infinity. You don't have to really know that too much, but it's a nice idea. It's basically if you've got to invest a certain amount of money and you compound continuously, okay, then what will happen is that your ratio will be E times your original amount. So the thing I like about E is that the original function, it's the only function where the derivative of the function is the same thing as the function value. So the gradient at any point is the same thing as the y value. Isn't that amazing? Yes, it is. Right. So now on to sketching these graphs, and it's really nothing new. You've done exponential graphs, you've done log graphs, you're just working with a different base. That's all. Okay. So if we said to you sketch f of x is equal to e to the x, remember e is just this number which is approximately 2,72. Okay, well, blah blah blah. Okay, so e is approximately 2,72. So now, if we sketch f of x is equal to e to the x, generally, okay, we know we label it in terms of e. Okay, it's always more accurate unless they specify on the graph, give your solutions correct to 2 decimal digits. Okay, so if our f of x is equal to e to the x, generally with an exponential graph, to get an idea of what's going on, I always sub in -1, 0, and 1. So if I go try sub those in, give you answers here in terms of e. Okay, so e to the -1 will be 1 over e, e to the 0 will be 1, and e to the 1 will be e, which is approximately 2,72. So here is 1 point. Okay, when x is -1, y is 1 over e. So it's -1 and 1 over e. When x is equal to 0, y is equal to 1. That's that point over there. And when x is equal to 1, y is equal to e, which is about 2,7. So we have the point there, 1e. So it's just got the shape, as I said, it's just a normal exponential graph, okay, where f of x is equal to e to the x. So I would definitely have that point 1e labeled, that, and -1, 1 over e. Right, so without even knowing anything about logs or anything, you could still go sketch f to the -1. Okay, because when you sketch the inverse function, what do you simply do? For every individual point, the x and y values swap around. So on the same set of axes as that one, I want you to go sketch f to the -1. Okay, the inverse of f. Off you go. Right, so if I swap points around, -1, 1 over e becomes 1 over e, -1. So I've got 1 over e, -1. Okay, 0, 1 becomes 1, 0. Okay, and 1e becomes e, which is about 2,7, and 1. So those are your points on the inverse, right? And if I sketch the inverse of f, well, you can see it's got the shape of a log graph, and that's because it is a log graph, right? Okay, so remember, so this is f to the -1 of x. In general, okay, if you've got f is equal to, don't worry, no one's having a p, things are just being poured in the background. Okay, shit, curriculum. F of x, the dog show here, is equal to log ax Okay, if f of x is log ax, then the inverse, see now I'm making mistakes. F of x is a to the x, then the inverse function is the log with the same base, right? You should be comfortable with that. If f of x is equal to a to the x, then the inverse is log a of x, okay? Hopefully that is familiar. So likewise, if f of x is equal to e to the x, then the inverse function is the log graph with the same base. So log e of x, okay? And the name we give, this is called the natural logarithm, and we abbreviate it to ln x, Ln(x). So ln x means log x base e, okay? So that is your inverse graph. So this is the graph of f of x is e to the x. The inverse is the log graph of the same base, so it's log x base e. But the way we're going to write it is ln x. Okay? So ln x, log x base e. So just like we said log x base 10, we write that as just log x. Log x base e, we write as ln x. Okay? And again, if I said to you what is the axis of symmetry between any function and its inverse, the axis of symmetry between any function and its inverse is simply the reflection about the line y is equal to x. Right. So now your log laws, well, ln is just it's like any other type of log. So your log laws still apply. So go write down those log laws over there, okay, and write what they change to according to the log laws. Give that a go, just to get used to the language. How's the soup going? Great.
Moving on to the salad, the bulgur and lentil salad.
Bulgur and lentil salad. Right, so ln x to the n is going to be n ln x. Ln xy is going to be ln x plus ln y. Ln x over y is going to be ln x minus ln y. Okay. The log of 1, that point over there, is always equal to 0. And remember, log base a of a is equal to 1 if those two things are the same. So log e of e is equal to 1. In other words, ln e is equal to 1. And you'll see there's a ln button on your calculator as well, which simply means log x base e. Righty. Okay. You guys get that all down. If you haven't got it down, I'm going to press pause so we can blend the soup. Domestic bliss. Right. Okay. I'm afraid the soup has not yet been made, but we shall carry on.
Well, I needed 20 minutes.
Well, you just have to wait, woman. Right. Solving equations involving E and ln. Now, the examples come from Mindborn AP Maths, grade 12, exercise 5, page 110. Okay. And the question says solve for x to 2 decimal digits. Just a reminder, what is ln x? It's log x base e. So ln e is 1. And just to change a base rule, okay, which we didn't discuss, if you've got log b over a and you want to get them to base e, so you have base e, then what happens? That b goes to the top, and that original base goes to the bottom. Okay, in other words, log b base a can be expressed as ln b over ln a. That's really the only change of base law I learned. Okay, well, you have to know, you can derive all the other ones. So all the questions in this exercise say solve for x correct to 2 decimal digits. Okay, and again, the laws that you've always used before for solving exponential equations, don't be bullied by e. E is just a number. So I want you to do this over here. Solve for x given e to the 2x is equal to 2e to the x plus 15. My hint would be to use as substitution. Off you go. Welcome back. Right, so just remember, if we said let e to the x equal k, and say I go square both sides of that equation, so I get ex squared is equal to k squared. E to the x raised to the power of 2, when you raise the power to another power, you multiply the exponents, so you get e to the 2x is equal to k squared. Okay? So in our substitution, where we see e to the x, we can replace it with k. Where I see e to the 2x, I can replace it with k squared. If I do that substitution in here, there's going to be no other variables apart from k. So then go solve for k, and then try solve. Right, off you go. So I get e to the 2x is k squared. So k squared is equal to 2k plus 15. Okay, move everything to the other side. And I get k squared minus 2k minus 15 is equal to 0. Factorize k minus 5k plus 3 is equal to 0. So therefore, k is equal to 5, or k is equal to negative 3. But I've got to solve for x, so I've got to sub back in. So k is e to the x. So e to the x is equal to 5, or e to the x is equal to negative 3. But remember the shape of the graph e to the x. Okay, e to the x will only spit out values which are positive. Okay, so this e to the x is equal to negative 3 is impossible. Okay, so all I'm left to solve is e to the x is equal to 5. And if you use your definition, okay, remember e to the x is equal to 5, we can write that as a log equation, okay, where log base e of 5 is equal to x. With practice, you skip out the step. In other words, ln 5 is equal to x. Then go to your calculator and just enter. Normally you could stop there, but because they've expressed in the question, so if they just said solve for x, we would stop there, but they've said solve for x correct to 2 decimal digits, so we do the extra step, and on your calculator, you work out x is equal to ln 5, do that in your calculator, and you should get x is equal to 1,61. Oh, a thing of absolute beauty, and I'd like you to admire, if you will, the wonderful handwriting.
Well done.
Quite exquisite. Okay. Hello. So, next question is question D from exercise 5. Again, solve for x to 2 decimal digits. And you've got ln x all squared minus 7 ln x, this is the lovely noise of chopping, is equal to 8. It's like background music. Okay, so give that a go. It should be crying at you. It should be saying, look at me, I need to do a substitution. Okay, so go give it a go. Right, and you're going to let k be equal to ln x. So therefore, the sum becomes k squared minus 7k is equal to 8. Therefore, k squared, k squared minus 7k minus 8 is equal to 0. Therefore, factorizes to k minus 8k plus 1 is equal to 0. So therefore, k is equal to 8, or k is equal to negative 1. But what was k? K was ln x. So ln x is equal to 8, or ln x is equal to negative 1. And remember, with exponentials, which have that shape, you can only get positive values out. But with log graphs, this is your shape of your ln x graph, you can have any y value. Okay, so both of those solutions, 8 and negative 1, are valid. Just till you get used to it, you might want to write ln x as log x base e is equal to 8, or log x base e is equal to negative 1. And to solve those, remember, to solve an exponential equation, we change to logs. To solve a log equation, we can change to exponents. So then this becomes e to the 8 is equal to x, or e to the negative 1 is equal to x. So if they just said solve for x, again, you could leave it, it would be better to leave it in e form, but they said solve to x correct to 2 decimal digits. So go use your calculator and figure that out. and you should get x is equal to 2980,96, or x is equal to 1 over e, which is 0.37. There's your answers. Correct to 2 decimal digits. A thing of beauty and a thing of joy is mathematics. Right. Good day. Just to start off, I'd like to show you what a multi-talented person I am. Look at these home-grown, delicious granadillas. Some are still waiting to ripen, but generally a food of the gods, made in my very own garden, planted with my very own hands.
Passion fruit.
Yes, that's the word they're going to use.
Passion fruit.
Ma'am would like to say that what she recommends is
Granadillas on all bran flakes with milk and sugar. You'll never look back. Best
Right.
recipe ever.
There you go, something that you might remember if you don't remember this maths ever.
A thing of passion.
Right, question F. Okay. It says the absolute value, solve for x to 2 decimal digits. Absolute value of ln x minus 2 is equal to 1. Well, first of all, before I do anything else, I can't remember how to do it for the last questions. Even though that's an absolute value, okay, this bit over here, if that log is going to exist, okay, x minus, don't forget your restriction, x minus 2 must be greater than 0, so x must be bigger than 2. So those are my only solutions. Okay, x is bigger than 2. Then, remember that if absolute value of x is equal to k, then x could be k, or x could be negative k, right? So, go use that idea to get the next line. You're going to end up with 2 log equations, then go solve those separately. Right, give that a go. So, if absolute value of ln x minus 2 is equal to 1, it means that ln x minus 2 is equal to 1, or ln x minus 2 is equal to negative 1. Okay? So, if you are more comfortable at this stage still of writing that as log e x minus 2 is equal to 1, or you don't have to write the step log, in fact I wouldn't until you're more comfortable with it. Okay, again, a log graph has that shape, so a positive or a negative can come out of it. Okay, so these are both valid. Okay, negative 1 and 1 are valid. So to solve a log equation, get it into exponential form, and using the definition, this will become e, the base stays the same, so the 1 is equal to x minus 2. And if we solve this side of the equation, we get e plus 2 is equal to x. Okay, and again, if they had said just solve for x, you'd stop there. Okay, but they didn't. They said give the answer to 2 decimal digits, and so you're going to get x is equal to 4,72. Remember, there's a button E on your calculator. It's somewhere on your calculator. Go find it. It's one of the red buttons on your Casio. Okay, somewhere near pi, I think. Okay, so I get x is equal to 4,72. So if you haven't done that side, go to that side quickly. Okay, and here, if I write this in exponential form, I get e to the negative 1 is equal to x minus 2. So in other words, 1 over e, you don't have to write it like that, you can leave it as e to the negative 1. 1 over e plus 2, what the hell is that noise? 1 over e plus 2 is equal to x. Shove that into your calculator, and you should get x is equal to 2,37. Right. Just remember, these videos are issued free of charge, so despite the background noises and the comments from the peanut gallery, there's no money to be returned. Okay, right, another thing of beauty. Okay, get that down. Right. Hello. Okay. So, next one we're going to do from exercise 5 is J. And solve for x to 2 decimal digits. Ln x squared is equal to 1 plus log e base x cubed. Okay. So, give that a go. Remember, you've got a problem. Your problem is that your bases aren't the same. This is the log base e, and this is the log base x. So the first thing I'm going to do is to try change that to log base e, so we can write it in ln form. Okay. So before we do that though, let's deal with the problem of the exponents. So ln x squared can become, it's just a log, 2 ln x is equal to 1 plus 3 log e base x, right? So I've still got this problem to deal with. So you can go learn those other laws by heart that we discussed the other day, but I generally just stick to your change of base law and do an extra step. Okay, so I'm going to have therefore 2 ln x is equal to 1 plus 3. Right, so now I want to get this to base e. As I say, with practice you can skip out some steps. So using this log law over here, I say, okay, I want base e at the top and the bottom. Okay, then what happens? This bit over here goes to the top, and this bit over here goes to the bottom. Okay, right, so I end up with 2 ln x is equal to 1 plus, well, log e base e, in other words, ln e is just equal to 1. Okay, sorry, I've still got that 3 at the top, so I've got 3 at the top, that 3 there, 3 times 1 is 3, and that is simply ln x, log x base e is ln x. Right, now, that's kind of yelling at you, substitution, substitution. Okay, so go try and finish that off. So if I let k be equal to ln x, then that equation is going to become 2k is equal to 1 plus 3 over k. So therefore 2k squared, k is equal to k plus 3.
Oh.
So 2k squared minus k minus 3 is equal to 0. Okay, I'm going to check the sum up here.
Salad is delicious.
So please do yield me please know the salad is delicious. Okay, so I've got 2k squared minus k minus 3 is equal to 0. Okay. So now I'll factorize that. And it must be plus 1 minus 3. So 2k is equal to 3. Or k is equal to negative 1. I've made a mistake here. So k is equal to 3 over 2. Or k is equal to negative 1. Let's just double check that. I don't know why I'm feeling uneasy. 2 ln x must be the peanut gallery. 2 ln x is equal to 1 plus 3 over ln x. So I get 2k is equal to 1 plus 3 over k. So 2k squared is equal to k plus 3. That all looks right. 2k squared minus k minus 3 factorizes to that. So I get k is equal to 3 over 2. Or k is equal to negative 1. Yep, it's all on track. Right, so go finish that off. So if k is equal to 3 over 2, what was k? K was ln x. So ln x is equal to 3 over 2, or ln x is equal to negative 1. Okay, remember ln x is just log base e, so this becomes e to the 3 over 2 must be equal to x, or e to the negative 1 must be equal to x. If it just said solve for x, you'd be done now. But it says solve for x to 2 decimal digits. So you're going to get x is equal to 4,48, or x is equal to 1 over e, and 1 over e is 0,37. Okay, get that down. One more sum to go. Hello. Greetings. Okay, so now the last one we're going to do together, and this one we'll put hair on your chest. Okay, so.
Does this class know the lawnmower song?
No, we'll teach to them tomorrow. Okay, so I've got ln x plus 4 log 1 over e x is equal to negative 3. Okay, so that could bully you if you're prone to be bullied, but just stay calm, okay, and apply your log laws. Okay, so the first thing is, okay, can move that to the front. That bracket actually doesn't have to be there. I mean, it could be just ln x, ln applied to ln x or whatever. Okay, so I can move that to the front. So it becomes, so this moves to the front, and it becomes ln x. Okay, that's moved to that bit over there is of ln x. I'm just using this law that ln a to the n is n ln a. Okay. So now we've done that, and then this will eventually become ln x times ln x is ln squared x. Okay. Over here we've got a problem of bases. Okay. So this is base e, so I want this whole thing to become base e. So we're going to use this change of base law. And if I use that change of base law, what I want the bases to be base e. So I want my bases to be base e, then what happens? That bit goes to the top, and that bit goes to the bottom. So that's going to be 1 over e over here. And 1 over e is just the same thing as, remember 1 over e is equal to e to the negative 1. Okay, so that's log e 1 over e, which is the same thing as log e to the negative 1. Okay, and remember, then log e to the negative 1 is the same thing as negative 1 log e base e, or negative 1 ln e, and that's just 1, so it's just negative 1, right? So I end up with this being equal to ln squared x. So that whole thing is just negative 1. Okay, so I get 4 divided by negative 1 is negative 4. And log x base e is just ln x. Okay, and that's all equal to negative 3. Okay, so there's quite a bit of nice maths going on in there. And now you should be thinking, substitution. Right, so go do a substitution. Let k be equal to ln x, solve for k, sub back, and solve for x. Right. So that should be a therefore sign. Okay. And that should have had, equal to negative 3, and that should have been therefore as well. Okay. So if I let k be equal to ln x, the equation becomes k squared minus 4k, move that across, plus 3 is equal to 0. So therefore, k minus 3, k minus 1 is equal to 0. So therefore, k is equal to 3, or k is equal to 1. Right, but what is k? K is ln x. So ln x is equal to 3, or ln x is equal to negative 1. Okay. I should have actually over here, again, got my restriction. I should have said x has to be bigger than 0. Okay. So we're going to get e cubed is equal to x, or log base e is e to the negative 1 is equal to x. If you put that in, as I said, if you'd been asked just to solve for x, you'd be done, but they said solve for x, nearly done, to 2 decimal digits. So you should end up with x is equal to 20,09. Children are starving. Everyone's frustrated with Roger John. Or x is equal to, hang on, I've done something wrong here. K minus 3, k minus 1. So that was 1, sorry. So x is equal to e, which is 2,72. So x is 2,72, okay, or x is equal to 20,09. Okay, and if you do that, there's not many log equations at this stage. They get much tougher than that. Okay, ladies and gents, the last thing left to do for today is read page 107 to 109 of your grade 12 AP Mindborn Maths, Calculus and Algebra. Okay, look at their examples over there as well. And then do exercise 5 of your Mindborn Maths, page 110. The ones that we didn't do as examples, so in other words, A, C, E, G, H, and I. I will post a memo for you. Not too many days to go before holidays. Okay. Stay strong, stay chilled, stay safe. Ciao.